Hi, this is Antminer Repair, and tonight we're going to look at how I try to locate a bad chip and how I test for it. A lot of you have messaged me and asked for this video. What was holding me up is I have the Antminer test fixture, they call it, from China, and they actually specify, hey, you need to hook this thing up to your APW9 power supply that's on your miner. And I have one of those, but I figured out a way with a regular DC thing to bring it in here. It won't hash, so that tester won't hash. It'll test for the chips, which is what we're going to talk about tonight, but then it'll start hashing and test each chip for the hashing power. And I'm pretty safe doing this because I know this board doesn't find all the chips. If it did find all the chips, I'd probably panic because it would probably blow a fuse on my DC power supply because it can't handle the amperage. So that's what we're going to do tonight. If you're interested in this type of stuff, please subscribe to my channel. Also, if you see that little bell there, that'll notify you when a video is available that I'm working on. And thank you guys for your donations. I have a PayPal address and a Bitcoin Receive wallet address. If you guys would like to make donations, I need to buy some more supplies as it is now, and it is pricey. So any help you can give me or any ideas for videos, that would be great. I'll try to accommodate them. Sometimes it takes me a while. I do have a full-time job besides this too. All right. So I'm going to give a quick overview. This board has 6 ASICs found. I already know the error. I already kind of know what's wrong with it, so I'm kind of cheating a little bit just so I don't stumble on video, because I've literally before stripped off all of these heat sinks and tested every single chip to find out what's wrong. In fact, the board I'm replacing the chip on and doing that series of videos, that's what I had to do. I actually found 3 chips wrong on that. So I'm going to use a similar process, except I'm going to be very localized. With the 6 ASICs found, I have localized the chip. It's on this side of the board, not on this side of the board. So I think we're okay with that. All right, so particularly with a 0 ASIC found, when you find 0 ASICs, there is a repair manual kind of on Zeus Mining that I found. It's in Chinese. You can use a PDF converter to convert it, and they kind of have a prescribed method. Kind of difficult to understand. Maybe if you guys speak a different language, it might translate to your language better. It was a little hard for me, so I had to just sit there and stare at it. It has some diagrams of the chips and stuff like that. Very useful, so you could go search around and find that. But usually the first thing you want to start, the way they say, is to test your inputs right here, way down in this corner. And this is where your slide bar goes in. And so make sure that you have power here. I can't imagine it not, but they want you to check there. Then the next thing, the next place you check for is, hopefully I can zoom in on this guy a little bit. My camera's going to be all over the place tonight, so I'll see if I can zoom just so you can see it. I mean, focus. One moment. All right. So let me see, what am I going to use as a pointer tonight? I will use my negative probe, since we're going to use that in a little bit. So when you start back at these guys, it goes to this pick chip right here. And this is a programmable IC, and you do have to flash these, especially after you replace a chip, because it loses its program. However, it has one leg out. It's probably either this leg or this leg, one of these legs. It supplies 3.3 volt out, and that really turns on the whole board. This guy controls when the chips get turned on. It communicates with the chips. It communicates with the motherboard and software. Motherboard, the main board on your system, not the hash boards. So the first stop is for voltage is when this guy decides to turn it on. He uses this chip right here. I forget, I can't zoom in with my microscope, but this chip's interesting. I looked it up. I did, there's a site called All Data Sheets, and if you get the number off the chip and search for it, you'll find the chip, and there's 3 legs, and one of them is I think one of these legs is like pumping in 17.5 volts. One of these legs is called enable, and this is called the output. I think they call it the drain, or can call it the drain. So what happens when this chip decides to turn things on, it sends the signal to enable, which turns on this which has 17.5 volts. When you hit enable, it pumps 17.5 volts out of here. And so if you have 0 ASICs, this is the first stop. You want to check this chip is good. If this chip's not pumping it out, you can actually look at the input leg and see if it's got the voltage. If it doesn't have the voltage, then it's got to be in the circuitry. But this is first stop. So far, I've never seen anything wrong with this guy, but I have checked it. So where this guy goes from here is over to these chips. And this is this weird lone heat sink on the board. There's nothing under this, actually. It's on the other side of the board, so I'm going to flip it. Yeah, let me make sure I can, let me get rid of my focuser and so I can see what I'm showing you guys. All right, so let me get down to the camera. So where are we? Getting there. Ah, there we are. So I'm at the top of the board right here. This is where the power comes in, and here's all the capacitors. Some of you guys' boards only have 2 here. But do you see this series of 4 chips here? 1, 2, 3, 4. The heat sink is right underneath here, and these guys get hot. And I don't know why they do this, but each one of these puts out 17.5, and they're kind of wired in kind of a waterfall kind of mechanism. So this one enables this one, enables this one, enables this one, and they all kind of feed each other. And then the output of this whole system, from what I can tell by the documentation, is 17.5 volts. And from there, to tell you the truth, I don't know where it goes. Probably through here, so it can pump these capacitors up and provide steady current. Even if these are kind of freaking out, these will act like batteries. One thing I haven't figured out is where does it go from here to get cut down to the 3.5 volts. However, that might be some here, although I don't know. I think this is support. There's some voltage regulators here. I think this supports the PIC on the other side, the programmable IC. There are some things way down on this side of the board. Let me see. I'm just going to flip it on its side. Sorry, my camera's real close. Maybe I can pick it up. Oh, let's go back up here and I'll try to refocus. So there is some sort of unit over here that I think might have something to do with the breakup of the volts, but there's like a 16 prong here and there's a big resistor here. But somehow, some way, each one of these lines of chips gets a separate line of voltage, actually 3 types of voltage, maybe even more that I don't know about. So if you've got power on the other side with that 17.5 and you've got more than 0 chips found, like 6, like this board, I already know the system's probably working. There could be something breaking on some of the power, like if there was only 6 found, maybe the rest of this power all the way across the board. I'm going to raise up some more, guys. Might have to focus again too, just bear with me. I'm going to be all over the place because we're going to look at the testing equipment, stuff like that. So let's see. It's about the best I can get there. All right, so I do understand how the chips are fed most of their power, and I do understand these test ports. I'm going to zoom back in for those yet again. So with that said, I think I lost my train of thought there. So if you want me to explain something else that I was going to explain that I didn't explain, please let me know in the message. I'll try to get back to it. On the back side of this board, when you start talking about, I'll probably zoom in on this guy again. Sorry, in and out, refocus. Let's just look at what's under this heat sink. This one's kind of special. I'm going to focus. Okay, so there's a couple things under this heat sink. Let me get my poker. So you've got this thing right here. It has 3 legs on one side and 2 legs on the other. Then you've got this whole row of stuff. I have never figured out what this whole row of stuff is. It has to do with power. There's a big electrolytic capacitor here and a bunch of capacitors, a couple resistors. They happen twice on each row of chips. I don't know what these are. However, I don't think they feed anything on the test port from what I can tell. I think they have to do with the big 3 bands of solder that go through. I think these power the main chip pad, which this is negative, and the positive and negative on the chip pad. I'm pretty sure that's what runs that voltage. The other little thing here, this happens to be on a chip that has a temperature sensor. So this is a T451 temperature sensor right there. And sorry for the glare. Let me see if I can. Yeah, it's kind of at the top. But this is the temperature sensor. And this has some legs that reach up into the chip. And this chip reports its temperature. There's only 4 chips on the board that report their temperature. I'll do a quick video on that alone, but this happens to be one of the chips with the temperature sensor, and the chip has output to this. So on the other side, let me move forward up to the bottom of the board. It looks like the top here. Let's make sure they kind of focus here. Hang on. I got stuff on my lamp like cameras and stuff. So, okay, so like that 5-legged thing, you've got 2 more of these. These are voltage regulators, and each one of these has a specific purpose. You can look it up. One starts with an SQ, and one starts with a 4 or something. But let me get toward the middle here. So basically, one of these, they're very similar. They have a voltage input, a ground, and then an enable pin. Those are the 3 on the one side. And then they have the output side, which is this top part on the 2-sided leg. And then they have a feedback pin. So what this does is it gives voltage. You can turn it on or off. And then the voltage adjusts on some of these depending on what feedback it gets. So some of these, you'll see some circuits with some capacitors and resistors here that feed back in the lower side of this. So I know these 2, one produces 0.8 volts and one produces 1.8 volts. And I think the one down below that I showed you before, down by that temp sensor, I can't remember if it's 0.8 or 1.8. I think it's 0.8. So these are the power circuits for the bank. And then there's one embedded on each side of the chip. There is an exception. If you go clear to the end of the board, this is the 0 chip side. But if you go clear to the end of the board, let me see if I can show you these. It's really hard to see. Let me, the board's kind of going up. You can kind of see them here. Because there wasn't real estate on the board, they've actually got 2 of them here, and then only 1 out here. So this first bank is a little weird, and the last bank, I think, is a little weird. The last bank, hold on, I'm running out of real estate. This is the other side of the board. If you look at it, I don't know where those dudes are. It has this, which I think supplies some power. That's my theory. And then it only has 1 of these regulators up here where the other banks have 2. So they've done something special for each end, which complicates things. All right, so those are the places you can test. You can actually test and put a pin on these regulators. It's very possible to, and I do check those. Be careful though, I have seen this chip be bad and it's not providing a sufficient ground for this chip to pump out voltage. Now one more thing is, let me raise it up just a touch so you can see more of the board. Let me get rid of my focus thing so I can see what I'm showing you. Kind of multitasking here, so. All right, and then I will focus again. One moment. Okay, that looks pretty good. All right, so these guys run across the top, and the way this happens, so my probe, and it'd be better to show you this in a microscope, but I could point it to it. They actually start on this. Yeah, I'm going the right way. Everything's backwards on video, right? They start on this side of the board. Now each one of these circuits is kind of weird. It has a big, I think, a 4.99 resistor, but off to the side is a 0 resistance resistor. And so what's weird is the power goes from the 0 resistor to the 0. This is the line. It does the circuit and then jumps out and jumps over to this one and jumps over to this one. So this distributes the power. I think there might even be 3 volts on this, to tell you the truth. This might be 3.3 volts going across each one of these guys into this 0 resistor, and it spreads it to the next one. Then it goes in this circuit with the 4.99, does some things with capacitors and resistors, and feeds these guys. These are the output of these guys. Might go the other way, I'm not sure, but that's how they spread. And then the output of these guys go down into the chip. Some of them go down to the chip, some of them get hooked up here in the test ports. I'm sorry I'm off to the side here, but these test ports. All right, so before we go test, it just helps to kind of know a landscape that things supply voltage. These are the test ports, and these are the back. These are on the back of the thing, and I kind of learned a lesson. You don't test. They're so easy to get on the back. I really like them. They're not in between the chip. That's one of the reasons I chose a board that didn't have heat sinks, because I really want to show you how to do it. On some of these, you're going to have to reach like in between chips, and you can't touch it, and that's why this needle is on here, for sure. So these are the 5 ports. If you don't know them, they're called clock, CI, RO, reset, and BI. I test most of these. The CI and the BI are a little bit flaky, especially the BI. It's clear at the end. I found that it doesn't have standard voltage. It can be high or low or whatever. It's a data channel. Reset usually does have the right power. I think it has 1.8 mostly. Most of these have 1.7. It's 1.7. RO usually has 1.7, although it can be as high as 3 if you're around the bin on these things. I've seen it when it re-energizes with another power supply. CI, I can't remember if it's 1.8 or 1.7. I just kind of compare it to the chips around it. And clock, this guy is who gives you your clock counter errors. He usually runs 0.8 for sure. So these are what these guys are, and these go through the other side of the board, and this is what I use to test the voltages. All right, so that's kind of the background. We're going to use these pins only on this side of the board. So let me flip over and kind of show you. I've repeated this before. I'm going to raise up again. You really kind of need the whole real estate of the board. This guy will stay up. Focus. Autofocus doesn't work, so I just kind of gave up on it. Okay, I know I got glare there. Sorry about that. All right. So the way these boards are designed, and you can see this, like around this, you see all these data paths. They start at chip 0 and then wrap around down here and then go up to the other line, wrap around here. It's how they do their calculations. They're just kind of doing a repetitive calculation. They pass it on down through the cycle. So this goes all the way through. And those test ports, they're in between the chips. You're kind of in the glare right here, but there's some right here. These right here are stacked. These are kind of mixed in between resistors and capacitors, but they're all over. And these guys down here are stacked. They're alternating in different places. If it's going around the bin, I call it, they're going to have test ports out there. If it doesn't travel this path, there's not going to be test here. So around here and around here. Okay. So the way my approach to this is to look at voltage, coming into the chip and back out the chip. And if the voltage coming in the chip is the same voltage as coming out the chip, or very well near, unless there's a reason for it, that chip should be good. There's a caveat though, is if the voltage coming in isn't good, it could be that the voltage coming out is no good. In this case, this complicates it, because if you see these resistors and stuff, on these cutouts on either side is where they apply new power. So each line of these has new power. So when it leaves here, it applies new power. So it gets a little dicey measuring this, but you can. So now on the regular board, what you're dealing with, on this side is these things are here. They're pretty accessible. You can't quite see it. But these are sticking out on this side. But the ones on the other side, so you got some in between the chips here, you can hardly see. Some down there. And if you don't solder your heat sinks on very good, like this one, it is there. I don't know. They're down there, but you got to get in between the chips to get them. And then if you look back here, they're going down there. Now, this one, I couldn't test because I might be able to reach it in there, but you can't touch the heat sinks. The heat sinks are essentially ground for all purposes, but you use your positive thing. So I didn't do a very good job on the heat sinks. Now when I put these back, I always try to be aware of these test ports and separate these wider, because this one's nice and wide, but there's no test ports down there. So I should have moved this guy over, moved this guy out, and it would have left plenty of room for me to test. So when you're putting back your heat sinks, be aware of where those testing things are, because even to test this, probably I would need to pull it off. Okay. So let me see, I think that's most of the prerequisites. So I'm going to flip this board around again. And I've got, I can't move it very much. I'm going to move my camera over. This is the tester I have. And I did a video right before this that it really, these wires underneath here are really a pain in the butt. And I moved it in from the garage and one of the wires broke and I had to figure out where it was broken from. I successfully figured that out. So I'm going to use this guy. This tester has an Antminer control board, but it has some special firmware that does the testing. And there's different firmware for each model, and it's a real pain. To get this installed, they give you one thing to flash it, and then one thing to run on the micro SD card. There's no instructions. Zeus sent me no software in the beginning, and then the salesman sent me some other software that was no good. And finally, he got fed up with me asking him questions, nicely, of course. Finally, he said, would you use our after sales support? And I did, and boom, they helped me out a lot. So if you have one of these, I think they can, if you're their customer, they've got really good service. There's another type of tester on the market that I've on a waiting list for that will really help, and that's a Russian model that does similarly. That'll work good. Now these guys say to test my board, I need to have my power supply on, and that's because after it checks to see if there's chips, it actually starts to hash and returns values off the chips, some expected values. And if the chips don't return the expected values, it says you got a problem with this chip. It's a pretty good tester, actually. It gives you this big grid of good chip, bad chip, and it kind of splits it up between input and output. Not always accurate, I'm sure, but it gives you really good guidelines on really basically where to start. So what I've kind of done here is I don't have my power supply. You're supposed to run fans on this to keep it cool. But one thing I noticed was that if you don't find all the chips, it just probes the voltage really quick, the right voltage, and applies voltage to the chips, then shuts it off. So the chips don't get hot. It doesn't try to hash with them. So I can use this in here without fans. I took the fans off. I can use this to show you the voltages. So to hook this up, it uses a data cable. He gave me an extra long one for this. Come on, baby. Good. I don't want that to be in the way of the video. Let me throw that under here. Now, there's not much you need to see here. I'm going to run it once. I'm going to show you it boot up on the screen. I'll share my screen. On that, I'll switch to my screen. But after that, we're really going to pay attention to the voltage meter on this, okay? But for the first time it starts up, hopefully the glare won't be too bad. How am I going to do that? Maybe I'll do it twice. Actually, I'm going to show you the screen. You can see the output of it when it's ready. So, and then once you've seen it boot up and stuff, what it acts like, I'm going to switch back to video and we're going to use the voltmeter and look at the voltages on all these. And I have to push the button for each time I test and wait a minute. So let's do that. Let me see if this guy's ready. Bear with me here. Okay. I guess I could keep no, I'm gonna shut off the video for one moment. I'm gonna share my screen. You know, I have this set up. I was running it earlier to make sure this all worked. It's not on right now, so this is what the question mark is what the heck are you doing? So this basically uses a secure shell, logs into it, feeds off a log, I think, of some sort, and then you can go back and review the log of all the stuff. So when I start it up, which I'm going to do right now, it'll start to boot. So I just flip the switch, and it's going to boot. And it really is just a faster way of of booting. It doesn't have to do all the hardware checks. It's not testing the fans. Again, it's special firmware. It takes a little bit. I don't have a network connection hooked on this, so it does a local net connection. You can kind of see it if you go through all this. Almost there. So what's on the screen right now on my blue thing is it just has some basic, very basic information. Might be able to see it. Hold on. I'll do this like this. A moment. Switching around all these sources. That's what it has. And I know it's probably backwards, but it has some BHCP, IC equals 30. So it knows my board type because I did T17 firmware. It's going to run it at 650. The voltage is 1750, 17.5 volts. Okay. So the first time I'm going to take you back is I'm going to reshare the screen and turn off the video. We're going to go back and forth because this is kind of hard to show in video, and I'm not going to post edit. It just don't have time in my life to do all this fancy video intros and stuff. I figure you just want to see the stuff. So let's go back to there. Okay, so there's a big blue test button on this. When I hit the green button, it starts the test. However, I don't have power. I don't have power on my board, so it's not going to go very far. I will lecture you on getting the right positive, negative on the board, but for the sake of not making you see switching between video and screen, I'm not going to show you that right now. I'm hooking up the power, and I'm going to turn on my power supply. Okay, and I have my power supply set for 17.5 volts on different boards. That would be different voltage, of course. Okay, so I'm going to press the green button, and here goes, and you're going to see the output. And then from there, I'm going to leave the screen because we're going to do this over and over, and you'd rather watch the voltage meter. So I push this button, boom, and it's going to test. You know, to do it pretty quick, it takes, what, 30 seconds, 45 seconds? Okay, so if this was successful, it would have kept going and start hashing, and that's when I panicked because I don't really have a real power supply on here. But if you look on that, it says ASIC number equals 6. It doesn't mean the 6th chip. It just means I found 6 chips. That's all there is. Okay, so I'm going to press test over and over and over again because it'll apply voltage. So let's get to that point now. So I'm going to stop sharing and get back to the video. Okay, now you see on the video screen, it might be backwards for you, I'm not sure. It says only have 6 ASIC, okay? So for the sake of tonight, we're gonna work on what that means. So that can mean 2 different things. I promised you I'd tell you about the power supply. On the 17, the positive is on the outside, negative is on the inside, okay? Other boards, that's different. I suggest you look at the bars that go through your power supplies on the Antminer S9. I'm not sure. I'd have to look. I probably will work a little bit on one later with a board bad. but I haven't gotten there yet, so I know this board better. So be careful, don't reverse them, or you're going to fix more than just a bad chip. Okay? All right. So let me see if I can fit the voltmeter in the video now. I'm going to have to pick it up some. Problem is, I'm going to have to tell you what test port I'm going to stick these in. Okay. So I set this to direct volts, DC, and you can't see it. There we go. Hopefully I won't move that. All right. So there is power on the board. If I go to the main things and look here, 17.5 volts matches about what the power supply is. But there is no power. For instance, if I look at the middle signal coming back, there's just noise power or none. See, I just probably seeped out a capacitor. So I did forget to tell you one thing. Out of the 5 test ports, one I don't test, which is the BI port, which is at the very end on one side of these. I never can remember, and I can't flip over the board. Oh, I can look at another board I have offline. So this would be, hang on. Let's see. So the clock is on the outside. So on this board right here, this test port is the clock. The inside one is the BI, I think, if I'm not mistaken. We'll find out because the voltage will be right. So, okay. So I already have been told by the testing machine, or probably by the Antminer itself, I only found 6 chips. So usually what that means is the input to the 6th, the output to the 6th, the input to the 7th, or the output to the 7th could be bad. Actually, the output of the 6th to both sides of the 7th to the other side of 8 going in. Now I suspect this one. A quick way to test this. So if it says 6, it could have been the signal that starts with chip 30 and comes back. And a quick way to test this would be to go find the 6th chip, which is here, and look at the middle port, which is here. So I want to make sure that after the 6th chip, this RO signal, which is the middle one, travels back. The others travel forward. So again, the clock, the reset, the CI, the, let me get them right here. I'm cheating. Not that good of a memory. The clock, the CI, the reset, and the BI. So there's 4 out of the 5 pins go forward. But remember, we don't test the BI, at least on these boards. The one thing that goes backwards is RO. So if everything was fine until it started going back and RO stopped around chip 6, it would have to be here. If I test this and the RO is good because this is on the way back and there's only one to test, if this is good, pretty much guarantee it's on this side and it's the other chips coming in. I really don't care what RO is coming out of here, because if RO was bad coming out of the 6th or 7th chip or whatever, it would say something like 23 chips found or 24 chips found. RO starts counting from here and goes back. The rest start counting from here and go back up. So it could be on either side, but how to tell if it's the reverse side is to check the RO voltage. So let's just check out what's coming out of number 6. Let me see if I can get my voltmeter so it can be viewed here. All right. So when I test this dude, hopefully this works. When I hit test on this button, we're going to wait a minute, and there'll be like maybe 1 or 2 seconds where it powers it. We should see probably 1.7 volts pop up. The other readings, if it's messy, it doesn't matter. I just look for the volts 1.8 or 0.8 usually. So I'm going to hit test, and it's going to go through its little test cycle, but we should be able to see it ping up to 1.7 if I did it right. Yeah, 1.8. That's close enough. Do you see that? What else is happening is it's staying on there, so it's not dropping. So I'm going to actually shut it off, because sometimes with these, and this card in particular, for some reason, it starts giving you, I just turned it back on, by the way. It's got to reboot. But sometimes it messes up the data errors and stuff, and I didn't want to keep running the voltage, so this guy got hot. I don't think it will unless it really gets to hash, but I didn't want to keep it on. That might actually be, if I can get it there out, I can just measure all these without pressing the button, but that's okay. So the output of this guy is pretty good. I could test the input to this guy to make sure he's got 1.8. If it's not, I have to wait till this guy reboots, and let me check that out. He should be rebooting by now. So he's still rebooting, sorry. We might have to reboot on the cycle. It takes a while. I'll tell you when I can hit test. So now I'm checking, I checked the RO signal coming out. I want to check the RO signal coming in. And if it's good, I feel relatively sure that between 6 and 7 is pretty good. To be thorough, I would go 7 to 8. I would look at the output of this chip, and it would probably be good too. And I'd say, look, it's not the return signal causing the problem. It's got voltage. That doesn't guarantee it. You could have a bad chip, and it has good resistance, and it has good voltage, and it's just a bad chip. And then it's kind of like you just kind of have to say, well, I'm going to replace that chip and see if it fixed it. All right, so we're booted. So let me hit this. Hopefully it doesn't happen again. We should be, so sometimes on these return trips, since it adds more power, I get 2 or 3 volts too, but that's fine up here on these ends. It corrects the volts going in to back to, yeah, so 3.2. I've seen this in the board's work. So I think we're fine there as far as that. That's got voltage. If it came around here when it's supposed to be 1.7 and saw 0.4, that's a problem. That means the input to this chip is not clear to get the voltage. The output's good, but the input isn't. So let's go find our bad chip. Let's see here. We might have to restart this a couple times. Sorry, that was probably not very cool. I had a screen above my thing. Okay, so I'm particularly going to start here. This is chip 6. It saw 6, but we don't know if it sees 7, and it could be the output. So I'm really not too concerned about RO, because that would be like chip 24. But what I am concerned with, let me see, BI, that one I don't care about is up here at the farthest point. I'm going to do the first one in, and I'm going to look at the voltage coming off the chip. So I'm going to hit this test button, and we wait. .7, okay? It's good voltage. All right, so I'm going to go to, the next one is the return signal. I can look at, just for the heck of it, let's look at the signal coming out of chip 7. I'm going to hit the tester. And if it freaks out again, maybe I'll just test them anyway and it'll go faster. As long as this board doesn't get hot. So this is coming out. This is the middle test port. Yeah, so there's plenty of voltage that came out of there. It was a little flaky because remember it re-energizes, so I always get weird volts going that way. This should be the reset port coming out of this chip. I just hit the test button. Hopefully something happened. Maybe I didn't do it. Yeah, it finished. Hang on, I didn't see any voltage coming out, so it means I didn't get my probe. The other problem with this is I have to test it over and over, because if you don't have things right. So I'm gonna hit test again on that, because I think this is pretty good voltage on this. Yeah, 1.7, so that's normal voltage. Guess what, I freaked it out again. So let's actually check the voltage on the clock. Hopefully it's powering that. Should be 0.8, that's the last one. Oh, it stopped finally, so I gotta press it. So this last one's clock. Clock usually runs on a 0.8. Check it out. I just hit test. Hopefully it'll do it. Sometimes after it freaks out like that, I have to reboot it. Come on. Yeah, I need to reboot this. Sorry, it's gonna take a while. So I did that whole board of the chip we were replacing on my other videos. It takes a long time. This one seems to be particularly sensitive and causes ASIC register errors on my tester quite a lot. So just a second, I'll tell you when it's booted. We're going to look again at that clock signal.